All right. Welcome to Recreating Tent Part 1. What we're going to look at is identifying first the base geometry. And what this does is allows us to see or allows us to determine what we should use as the starting geometry for all of the work that we're going to be doing on this. Now, the base geometry is going to need a few different things, one of which is going to be we want to make sure that we can find something that is relatively uniform throughout the part. And in this case, we can see that we have some circular component or some cylindrical component that seems to run all the way through. So don't worry about the fact that it has different faces and curvatures and all kinds of things. This is very much a kind of part like they might give you guys for the CSWA. So in order to get you guys ready for the CSWA, you'll hear me say it over and over again. My teaching strategy is similar to that of a particular movie, that if you can dodge a wrench, you can dodge a ball. So in order to get you ready for the CSWA, I'm going to treat you as if you're taking the CSWA every week. Now, this part has a couple different features that we're trying to recreate. One is kind of this base cylinder. And then we have some kind of a U-shaped collar over the outside. All right, well, that kind of makes sense. Let's see what we can do with this and how we can make sense of it. So we need some dimensions. Well, what dimensions? There's a few. Don't worry, we'll get to why we need all of those. So we're going to start by looking for a side view, a top view, an end view, something that gives us information. And we want to pay attention to what these symbols mean and where the arrows are pointing, because all of that information is very important for how something is defined. So up here for this, what would be a top view, we have a dimension listed here, 22 millimeters as the outside. Now out here, we have a different value, and we don't know exactly how thick this is from this particular view. So we'll figure that out here in a little bit. But one of the things that we want to pay attention to is we want to pay attention to where this base extrusion is. So we've got our 22 millimeter diameter, and then we have here a total length of 62 millimeters. So our overall length for the whole thing is 62 millimeters. So that's what we're going to start with as our base geometry. All right. So because of the way that things operate, we're going to start a sketch. We're going to start one for this one. It's going to be on the right plane. I'm going to change views so that we're looking correctly onto our part. So even though we've specified a dimension here, we need to tell it, hey, this is a 22 millimeter diameter circle. Then we're going to need a couple other pieces of information. And this is where you can just hurry up and extrude. But I want you guys to start learning as part of this process. Again, we're trying to kind of scaffold 862 different layers of learnings into this process, so that you don't really have a good sense of all the things you're learning at the same time, but they're all going to work together. This is an okay starting point, but I want you guys to vote in the chat. Is this the best starting point, or should we try and collect just a little bit more detail in this first sketch so that we can do more stuff and things at the same time from a base sketch? Let's take a vote. Yeah, so we should definitely do a little more detail, right? because this cylinder looks really not much like our existing part, at least not yet. Okay, so let's go back and let's edit that. So we're going to go back. We're going to edit that base sketch. Again, we're going to reset our view. All right, so we've got our base sketch. We move this toward the center. Here we go. Redo our base view. So that stepped me out of the sketch. I'm going to redo our base view here. There we go. All right. So every once in a while, this particular mouse does not register the clicks. Careful with off-brand Chinese mice. Maybe just avoid all of those on wish.com entirely. It's not where this one came from, but I'm told those are not high quality parts. All right, so we need a couple other features. Other features that we want to include are, let's kind of think a little bit about these two. So here and here, we have some important details, but we want to think about what is it that makes these so important? How is it that these are giving us information? Well, one of them is we have the radius for this interior, right? So the depth for that first extrusion is listed up here at 62 millimeters. So that extrusion height is 62 millimeters. We're going to work from this interior or ID, this inner dimension, inner diameter. They're used to mean a few different things, but it's all the internal dimension of that object. If it's a circle, it's probably referring to diameter. So this is 8.75 as a radius. That's what we want to include as one of the next pieces here. So we need our interior sketch, and the radius is 8.75. Now, this gives us a little bit more usable detail. So 17.5. Now, the next thing we need to do is we need to look and see what our, come on now, there we go. We need to look and see every once in a while when you're screen sharing with Zoom, it does stupider things than you would expect it to know how to do. There is another dimension here that's key, that's really kind of hard to see. And that's 36. It looks maybe like it's referring to this circle. And a lot of you on CSWA drawings are going to see something like this and get fooled, but you actually want to pay attention. And I'll zoom in here to make it real obvious what's going on. If this were referring to that circle, what it would have to do, so I'll use green to denote dimension. What it would have to do is it would have to cross the center point of that circle, which is roughly about there or so. Now, that's not where this ends. This circle, however, if we bring this straight down, so we don't have any jagged lines, and we bring this sort of straight across about the midpoint here, that sure looks like the point right here. That's where this is actually measuring. So this is actually measuring from the center of this inner circle to over here, the center of this circle in the front. So that's actually the depth of cut for this. So there's a couple ways that we can approach this. And I'll show you one of them here. We can use the same sketch to do a couple things by doing different kinds of extrusions in different directions. So let's look even just at what additional detail that one circle gives us as far as the mechanics of how the drawing is going to work for us. So if we just leave it at this level of detail, what we can do is we can come back out here and do, got to select that dimension, step out of the sketch because reasons. So we're going to do an extrude. And in this case, I'm actually going to edit this extrude. So first things first, I'm going to tell it, hey, instead, what we want you to do is we want you to take both of these regions, and extrude those forward. But instead of the 62, we're going to do a little math. That depth was 36. So what's the difference between 36 and 62? Somebody that's still awake, let me know. Good. So 26. So I've done one operation on this sketch. Now I'm going to do another one. And instead of doing an extrude, then coming back and doing an extrude cut, what I'm going to do is I'm going to recognize what features I need to capture. I need to change the direction of this one and tell this side to be 36. So now I have captured actually some very important details and given myself a reasonable reference point to do some of the next operations. So I want to do now another part of the geometry that we're trying to reference. Okay. So another part of the geometry that we're trying to reference, which feature do you guys think? Let's take another chat vote. Let's see what feature we should try and look at next. Do we need to do the front cut of the nose, or do we need to try and figure out this whole U-shaped piece business? What do you guys think? What would be your instinct? So in the extrusion process, where that comes up, we'll look at the U shape next. In the extrusion process, what you need to do is you need to control by expanding the select contours. You need to control specific regions. So you're going to have to often hit clear selections and then highlight a specific region for what you want to do the operation on. So that's one of the key skills that we're going to use over and over and over again. As far as dimensions for this, we don't want to start just throwing this on there yet. We want to start figuring out, based on the drawing they've given us, where do we put it? So we know a couple of things. We know that this 26 millimeters happens to be that difference. So that cut, that recessed cut, goes all the way up to this plane. Okay. That's interesting. But this starts a little ways away. So how far away does that start? Can anyone see it in the drawing? How far away from that center plane do we have to situate some kind of a plane for making this U-shaped object. Good. 4 millimeters. 4 millimeters also tells us something else that we'll come back to, but we'll see why. All right, so let's do that. Let's set ourselves up a plane. And we need an offset. So we're going to need to rotate our view, and we're going to need to reference this, but we don't want 10 millimeters. We want an offset of 4 millimeters. So we're going to say okay. And then we're going to make this just a little bigger so that we can make the features on it that we want. So we're having to make that whole U-shaped part on this. All right. So plane 1, we're going to need to recreate this process. So I'm going to change the view so that we're working on a square basis. We're going to create a new sketch on this plane, and then we're going to set up some kind of a circle. You could do an arc. I'm going to set up a circle just to give us a couple reference points later, and give a little definition to what we're doing in the sketch. And then we're going to set up a rectangle, and we're going to reference these points. It will kind of snap to these dimensions as you're scrolling past, but it's a very soft snap. So this is why you want to make sure that you have a decent mouse with a decent sensor in it, because you want to be able to actually make use of that snap, because this point is coincident to the circle. This point is also coincident to the circle, and that's how you verify that it's in the right spot. So we're going to need a few different key dimensions. We're also going to need another thing, since this we know is some kind of a U-shaped cutout. We're going to need some kind of a thing down there. So we know, even though this isn't centered and dimensioned yet, it gives us a starting point. So this is what we're going to work from. We're going to cut out some of the stuff we don't need. Like, for instance, that top bar, this lower circle, and this lower leg. So we're going to need something like this. We're going to set up our dimensions based on the drawing, and this will allow us to get a lot of that geometry recreated, but do so in a way that makes a little bit of sense. So let's go back to the drawing for reference. And we need a little bit of information. The first is we need to know how big it is. Well, that happens to be right here. That dimension in between these is a diameter of 32 millimeters. So that's what those symbols indicate. We really want to pay attention to the difference between diameter and radius. A radius being a single arrow and having an R, diameter being a circle across through it. Those become very, very important for understanding. A couple of you kind of got caught by that in some of our first early drawings. So just something to pay attention to. So 32 millimeters outside dimensions. 32 millimeters. So here we need this distance. I'm going to have to see about switching out this mouse, because this is creating some extra steps. All right, so 32 millimeters is our starting point. Then we need a height. So we'll get to depths and what all that business means. Here we go. We need some information about this business. So this height at 17.5 is important. And this at 18 is important. So 18 and 17.5. Let's do those real quick. Okay, it actually selected the tool this time. So 17.5 and 18. All right, so we're looking a little cattywampus. That's fine. Cattywampus is a technical term. Feel free to look that up on your own time. All right, we've got some of the key information. This is another piece of information we need, which is 7 millimeters. So we need to set these, there we go. Need to set both of these to be 7 millimeters. All right. So this one is 7 millimeters as it ought to be. And now we need to set the actual height here. So where do we find that? Well, we happen to find it here at 29 millimeters. So don't trust that it'll reload those tools correctly every time. 29 millimeters. All right. So now we're starting to resemble the geometry that it needs. Next, what steps do you guys think we're going to take for this? What do you think are the next steps based on the drawings? Okay, fillet could be. But we've approached it this way a little differently than some of the other approaches might suggest. So let's take a little closer look at our drawing and let's start with this. We need to know the extrusion depth. So in this case, it's going to be 20 millimeters. And we want to think about one more thing. We'll do this first just so that you guys can start thinking about it. I'm going to go ahead and extrude this. Needs to be 20 millimeters. Okay, awesome. Before I reveal it, anyone figure out what we missed? So think about our drawing for a second. So we're missing some information about this part. There's a couple other operations that have to happen. We have to do this side cut on the nose. But what else did we miss? Uh-oh. That depth is wrong. So no, we haven't missed the little holes. But this depth is wrong now. Because what did we forget? we need to change that base sketch to include our 22 millimeter circle. The reason we need to include that is so that the region that we extrude I'm going to go to extrude this. Okay. So now we've fixed the extrusion and we have the correct depth. So it's very important to make sure that you are paying attention to those kinds of details. Next, we can start thinking about some of the filleting and some of the other features here. But we don't need to do that until a little bit of a later step, and you'll see why. So next, let's go back to our drawing. And let's think for a second about what is it that we need to focus on next. We can do the filleting for some of it. We can also do some of the holes now. We can do some of the chamfering, or we could do this nose cut. So which feature would you guys instinctively work toward next? Would it be the hardware holes? Would it be, what would it be? So I would probably also pick the nose cut, just because that's naturally how I think. Doesn't mean it's right or wrong, just means that's the thing that I would pick to create something as close to the actual geometry as possible. Let me give you a hint as to why. If I were doing something like the CSWA, for instance, one of the things I would do is try and get as much of the material, the big cuts, so taking material away, are going to get me a lot closer to the actual mass of the real part than focusing on all the filleting all the way around. A lot of reasons why you want to pay attention to those sorts of things, but for now, we'll just focus on these particular details. So here's a couple features that we want to pay attention to. This dimension, we need to know how far that cut is going to be. So 26, and then this is about a 1 millimeter depth. We can estimate that that's about a millimeter, but it's nice to have an actual measurement of that. So 26 minus 1, because reasons, millimeters. And then for our width, we look at our other drawings and figure out if we can find it. So we don't find like a height over here, but we do find right here a thickness. And that's the number that we're looking for. So 16 millimeters. And then we're going to make it a 25 millimeter depth. So we're going to need another sketch on this front end. And I think it'll become clear why it is that we separated out this process. We want to do a 0 offset plane. We're going to do a 0 offset plane. On that plane, there was a sketch. And no, I'm not going to break out into song, as much as that would entertain most of you, but embarrass those of you that are trying to attend class in public. And then we're going to do a center point rectangle, because it'll be a little bit easier to manage. So we know the distance between these needs to be 16. The height here is a little less important. We are going to need an arc. So in this case, I'm going to use a 3-point arc instead of a center point arc. A couple of reasons why that is, but we're going to bring this down to be concentric. I'm going to follow this curvature. What I'm doing with the mouse is I'm trying to highlight this curvature and then reach this line at the same time so that I'm intersecting roughly where that curve actually is. But again, as these are geometric approximations, these are represented by polygons, not as true circles. So there's our first piece. We're going to need the same thing down below. We're going to bring it in, and it's smart enough to know what association we're making there. But we got to be real careful with our referencing. Okay, there we go. And we want to make sure that this is touching along this arc, which interestingly, we lost the association there. Let me go back and redo this. So these can be a little bit tricky to try and get references on an already extruded body. So I guess that, let's see if I can get it to force this. All right, maybe not. We're close enough that the software association for these points is going to be pretty close. So I'm going to have to estimate it here because I've lost the reference point. You can sometimes come back here and force it by finding a midpoint. Usually you can find an arc if you've made that reference elsewhere, but in this case, it's giving me a little bit of trouble. So trying to show you guys a few different approaches to how to do this. And we're not going to need a couple of these items. We're going to come back in and redefine some of our dimensions. Get rid of our reference lines because we aren't going to need those. All right, so we have our first enclosure. Now we're going to do another 3-point arc that's going to come up from these points. And this one will set a radius, and we'll get all of that key dimension information from our drawing. And we're going to add one more geometry that's going to be a corner rectangle. And again, think of this as the sort of negative space that we're going to be using as a cutting die. So we need an enclosed volume to be able to make this work and cooperate. So we've got 16. We've got this arc should have a radius of 11. This arc should also have a radius of, yeah, see 10.95. Not quite. Not quite. Should have a radius of 11. And this separation distance should be the same. Okay. So this is going to have a different radius. Let's take a look real quick. A radius of 8 millimeters for this outer circle. So we'll go back to our drawing. We'll have to deselect and reselect the Smart Dimension tool and a radius of 8. So because of the 16, this is already defined. I just happened to get it to the right exact height, which gives these, this is not quite the midpoint, but really, really close if you look. So that's why this is coming out dimensionally the way that it is. All right. So I'm going to step out of the particular tool here. One other thing that you want to pay attention to is setting a smart dimension. That one, it has the information for. So I want to check one more. See if it has the information for this direction. Yeah, 7.52 is okay. What we did by adjusting that radius is we changed where this endpoint and this endpoint of the arc actually interact. So this one is correct. The other endpoint might be very, very slightly off. So we've got key information. This should be an over definition, but because we deleted the lower reference point for the arc, because we deleted that lower reference point to enclose the rectangle and we deleted some of the center point data, it needed additional definition, even though we know that that distance for these lines is 16. Now we know that the distance between these 2 points is 16. So it hasn't done a misalignment or anything like that. All right, so we've got full definition for that part of our sketch, which will be important here in a little bit. That detail allows me to get some of the last things that I need to be able to show for this geometry. And I'm also going to make, I think, one more version of this. I'm going to make one more modification to this for the real life part, because I think I see a weak point in the design for a printed material versus a printed material versus an injection molded material here. And at the moment, I no longer have the fancy resin printer where I can get nice isotropic properties. But that could change here before too long. So let's take a look at this. This section, what's this going to do? This is going to allow us, and why did I do it the way that I did here? This section is going to allow us to do a cut. And there's a couple ways we could go about it. I'm just going to make a cut this way. We need to make the depth of that cut 26 minus 1, so 25 millimeters. Now, I'm going to go ahead and make that cut 26 millimeters, and you'll see why I made a change from a minor change from the real life component. So if I do 26, what do we see? Daylight. Broadly speaking, in 3D printing speak, if you see daylight in components that are meant to be supporting joint and they're going to have a lot of stresses, probably a bad idea. Skeletonizing or lightweighting 3D prints isn't often the right way to go. I mean, it's fine if you're doing certain things, but if you have a real mechanical load for something like, say, wind loading on a stressed joint for a tent, for instance, you really don't want to see daylight. So I made a slight modification there, added some material back in by going just 1 millimeter shy and changing this radius to be a couple millimeters so that at the thinnest point, I should have approximately a few millimeters of wall, which is quite a bit stronger than being able to see through it. So a fillet would have rejoined the material, but not as nicely. So we did one operation. Now we're going to do another one from that same sketch. We're going to do an extrude, but this time we have to go the opposite direction, but we can leverage the geometry that's in that same sketch. So we're going to do an extrude here. The problem is we can't do it from the sketch plane. We have to pick another face. Now, this has an extrusion depth all its own, and I'm going to set it to be 20 for right now. We're going to come back to our drawing and get more accurate dimensions. All right. So somebody who's good at math, what's my actual extrusion depth for this? Because it's not 20. What is it? What's the actual extrusion depth for that top feature? Good, 18. So at least one person is still alive and awake. That's a good start. So 18 millimeters. Now, when we go to do some filleting, there's a few things that we're going to find. So we can do some of it, but we're going to see where we maybe have missed a step here. So let's start doing some filleting. So we know there's filleting on this outer edge all around this U piece. We know there's some filleting here on the sides. Okay. We know that there's some here at the back. We know that there's some here at the front. So when we're talking about this, what fillet data can we find here? The answer is actually quite a bit. So we see a radius of 2 at this fillet, a radius of 2 at this fillet. We see this thickness of 4 millimeters. What are your guesses as to what the radius of that fillet is, since I didn't measure it directly? Then we see 20 exterior, 18 interior. So we know what this radius is. But what do we think the radius is for this fillet? Good. The fillet happens to be 4 because I decided I wasn't going to be as mean as I could be. So we're going to add a fillet. We're going to do 4 millimeters, and we're going to go all the way around here, and we're going to select these edges. Now you can do a couple different things with how this is done. And if you select both of those, let's compare this real quick to our actual part. So let's actually do it here in this view. So let's move our part to make it a little more clear what we're comparing here. All right, so if we go back and forth between our drawing and our part, Guess it's a little bit more shallow like this. Okay. So the difference is that fillet only goes to this edge. Okay. So we got to make changes. If we delete that second edge, we can recreate this. What's another way that we could create that fillet before this part is in the way? Anyone know? We're going to redo this. First, we're going to roll this back. I'm going to roll this back and do it here. So we'll look at the second edge of the fillet here in just a second. We can alternately roll back our part a little bit, and we can create the fillet first at 4 millimeters, and then roll the rest of those features back. So this creates the same feature, the same geometry. So I'll undo this and I'll redo a fillet. Now that we have that part, is a little different than what I showed on Tuesday. But up here, you select which items to fillet. Because I could run around and just go edge happy with 4 millimeter fillets. The problem is, on a corner like this, you could select a 4 millimeter fillet. However, you can't do that and also this, because that would create a confused geometry. So we want to control each time we're doing an operation what that looks like. All right, 2 millimeter fillet for some more of these parts. So here, this is instead going to be a 2 millimeter fillet because of what we've seen from our part. I have to complete that before I can jump back over and take a look. So we have a 2 millimeter fillet. We have our 4 millimeter fillet. We have another 2 millimeter fillet on either side here. And then we have a collective 2 millimeters worth of fillet here, but they're actually a radius of 1. So when we go back to our part, we can do a couple more of these pieces. So right here, we want to select these edges. So that one is a 2 millimeter fillet. So now we have a smooth transition, and that will help to reduce some of what's called stress concentration right at that point. You'll learn about that in the materials classes that you'll take later. Stress concentrations are going to do a couple different things and make your part vulnerable to breakage. So that's why I had to change the extrusion depth right there and increase the size of this component so that it would actually help reinforce the overall geometry in all these different types of bending loads that wind forces are going to subject that part to. So we also have these bottom edges, and we need to select. So often you want to zoom in and select them manually for a fillet. Question is, we're going to have to determine how big a fillet. So we'll go back to our drawing and see. So maybe it was about 6. I don't know. Maybe that's right. Let's go take a look. No information here. No information here. No information here. Aha. This one tells us that that line starts about 8 millimeters up. So that transition in geometry. So that's how we know we have a radius of 8. So our radius actually needs to be 8. And on the real part, it's just a little steeper than that. So it's pretty close. The radius is probably actually 10 because it does come to a rounded curve at the bottom. But for this purpose and being a printed part, I want to make sure I've got just a little bit more material supporting in the thin areas than the original part did. So I have to play around with a couple geometric realities to try and make sure that this 3D printed component will be able to last. So the thin area here, it does have quite a bit of tube recess into the center, but I'm concerned about the wall thickness here not being sufficient in an additive manufactured part to be able to replace and serve for the same length of time and the same duty cycle. So that's what we're going to change before this part is done. And then I'll print a final version of this and see if I've got the extrusion settings just so. All right. What we want to pay attention to next is, now that we've got that big part of the geometry, we can do this fillet. So if you select this edge, it'll do the whole thing. 8 millimeters is going to be much too large, but 1 millimeter you can actually manage. And what that does is the 1 millimeter smooths out all of those edges. So by the time you're done doing the additive manufacturing, you're not actually doing, you don't have, similarly to mold making, you don't necessarily want lots and lots and lots of sharp edges. That's very bad in mold making. Very hard to get sharp edges, and overhangs are while doable and possible, they're even worse in mold. Sometimes you have to destroy the mold to get the part out, and that's kind of stupid. So this one has a radius, the difference being 15 and 18. So the difference being 3. That has a radius of 3. So we're going to do another fillet on that part. This is going to be a radius of 3. And the radius for this could be more aggressive. I could have done a much longer taper and still gotten close to the same strength. I'm just trying to make sure that in this geometry, any kind of torsional load or any kind of bending load is going to be translated from this hole. It's going to be translated into the thickest part of the print. And that way there really isn't, in either direction, there really isn't any kind of bending moment that's going to overcome the strength of materials or strength of adhesion of the material itself. So there'll be some kind of R&D on the part of my end user to see which one actually works and holds up under the constraints. So let's see, we've got a couple people dropping off connections. Okay, I think we're back connected to audio again. All right, so what we've got for the last part here is we're going to have another fillet on this nose. So the fillet on the nose, we have some information about right here. The radius of 11 is the exterior. The radius at the front is 8. And so this gives us another 3mm fillet at the nose. So for the top and bottom, we're going to use the same 3mm fillet. Again, on the real part, it's a little bit more aggressive. I think the actual is somewhere around not quite 8, but maybe closer to about 6 is the real part. But because this is a key hinge point, as long as the clearance is okay here, 3 gives me a lot more material to support any kind of shear loading so that the pin doesn't break. So again, very slight modification to the base geometry. All right. So we've got a lot of our features recreated now. And if we compare it to our drawing, we're starting to get pretty close. Okay. So what are some of the final steps here? We want to make those holes and we want to set up that pattern. So let's take a look and see what we would do next. We want to add one more plane on this side. And I'll set the view so that everything is square, make life a little easier. And we're going to set it as a 0 offset on that drawing face. So this is going to be plane 3. Okay. Now, this part, I think I'm actually going to use the fillet to do something creative for that last step. So we'll come back to that. I think instead of changing the base geometry here, I'm going to do a fancy trick with the fillet where we're going to use the asymmetric property to do the modification, because I think that'll be a fun way to do it. All right. You know you're in danger when your CAD professor says we're going to try something fun and different. Okay, center line. These become very, very important for a lot of reasons. I'm going to cheat and use the center point here. And then my vertical reference. I'm going to do another center line. Remember that there is a big difference between lines and center lines, so you can't actually complete the geometry with, I think this one actually does need to go through the origin. If I remember right, we'll double check against the drawing. It's designed to locate these pins where the material is going to be strongest, which should be the center line of that axis. But there might have been a slight misalignment on one of them, I have to remember. So this, I can't really cheat. I'm just going to use that vertical reference to make sure that these two are perpendicular. And then I'm going to have to set a couple dimensions as far as the spacing goes. So here, yes, this is right at the center line. There are a few different holes. Again, there's a reason for this, and we're going to figure out what that is. We're also going to do a real quick assembly creation from this part and see what we can make happen there. Center to center separation of 30 millimeters. So let's do that. Center to center separation of 30 millimeters. The center to center distance becomes a very, very important one. All right, so 30 millimeters. Now everything is defined. All the center lines are defined. It knows where everything is, and we're going to create our base geometry. So we have 1, 2. We have down here. This one also has a set separation distance. I'm going to use a centerline reference to do this one as well. I'm not going to associate it with anything other than the horizontal reference right now because reasons. I'm going to go ahead and add this front circle. So be careful not to grab the midpoint of that center line. You want to grab the actual intersection point, and 2.05 sets our base geometry. So this is a 4.10. What this is, a 4.10 is 4.10 millimeters. This is a clearance hole for 4 millimeter hardware. Usually you need an additional 1/10 of a millimeter or so. The overlap and slight imprecisions of 3D printing can get you a couple difficulties in terms of the overall usable range. So this one is also going to be 4.10. Actually, I think I may have it as 4 in the drawing, but it actually needs to be 4.10 for clearance sake. And then the back, that one at 3.2, I think that one's actually just a little bit small. I'm going to kick that up a little bit to about 3.5. Couple reasons why. And there we go. All right. So 3.5, I can probably even get away with 3.6, honestly, but we're not going to worry about that right this second. I'm actually going to tap and thread the other side of those holes. Let's check the separation distance, center to center. For this guy, 21.07. So since this part's not going into space, the dimensions are, while important, the 0.07 versus just 21 is not really all that critical. There's going to be some measurement error by eye. Okay. There we go. All right. This one, same deal. We're going to do 2. We're going to set those with smart dimension. I'm going to do 3.5. What the 3.5 is going to do is give me a little bit of material to actually cut threads into. And this outer hole is going to be a clearance for the hardware. So I need the inner hole on the opposite side to be threaded, and the top hole I need to be chamfered. So we're going to see what that looks like. Chamfered for countersink of the pan head of the screw hardware that's being used. So you'll see what that looks like. All right, we've got enough detail. So now we're going to do our extrude cut. So we're going to start with an extrude cut. Notice that especially for these sections, it's doing an extrude cut of that annulus. That's actually not what we want to do. So we want to select the contours. We want to delete the sketch in its entirety and say, actually, we want to do the interior volumes or the interior area. And then we're going to do a special kind of cut called a through all. So that's going to be cut 1. Now we're going to do a second cut because we need this diameter to be a little smaller. We need this diameter to be a little smaller than this one. And there's going to be some assumptions that you have to make on any of these kinds of projects. So I'm going to do another extrude cut. I'm going to reference that drawing again. And now I'm going to do the annulus cut, but I'm not doing the whole sketch. I'm only doing the annular regions here. And I'm not going to do a through all. I'm going to do what's called, I'm going to show you a couple different options. You can do up to surface, and you could click this surface. The problem is up here. If you did that, you're not going to get the through hole all the way through, and your hardware is not going to fit the way that you think you can. And you can't just go, okay, well, since that one's farther, I'll just click this face, because it doesn't understand how to do up to that surface of the cylinder exactly with this one. It could if it was just the one, but it can't with both. So that's not going to work. So you could do up to vertex and say right here, but it has to actually find a point there and really, there we go. To vertex. So it won't allow you to select that one. So what you actually want to use is up to next. And what that will do is that will create, instead of a blind extrusion, that will create, there we go. Now it's actually displaying properly. SolidWorks being helpful again. That will create different depth cuts. There's occasions when you use this feature. It's not very often, but I wanted to show it to you guys anyway, so that you know that it's there and know what it does. Because you can't use tools to do cool things unless you know that it exists. So very different depths. And that's a very interesting way to solve this particular problem. So now our second cut extrude is done. The last thing we need to do is do our chamfer, which is under the fillet. And we want to select both these top edges. 10 millimeters you can see is a little bit too big. 6 millimeters looks, well, nothing like what we have. 3 millimeters is a little bit better, but still a significant amount of material we're taking away there. We can also change the angle of these. But pretty soon you cut away most of the material and it can't really resolve the geometries. So we're going to reduce this down to 2. And we're going to go the opposite way of this angle. There's a couple ways that you can do that. One of which is you can say, you can set an angle and then go, oh, actually, I actually want the complement. Oh, it's not going to let me switch them. Okay. So this one, this feature, you do actually have to do that. I think it'll let you flip the angle. Yeah. So it will let you change the direction. There's an asymmetric thing we're going to do for the other one, so I'm not going to do that here. So 25 degrees is actually about what you have in the countersink for a lot of these. All right. So now let's take a look. Does our example here look like what we have in the drawing. I would say that's pretty close. All right. So now, in order to modify the part for one more aspect of strength, I'm going to show you one more thing that we can do that's kind of a neat feature here. And this will help to make this part stronger and create less of a stress concentrator so that this collar won't have a tendency to want to just split along the center the first time this is wind loaded, and there's any kind of moment applied to twist or torque this particular bar under wind loading. So if we go to select that feature, we see which fillet it is. I want you guys to play around with a new aspect called asymmetric. And I want you to think real quickly about kind of what that looks like and how that operates for you. What things can you do with it? What things can you not do with it? And what kind of asymmetric details can you actually include? So what do you guys think? We can do asymmetric. What can we change? So we can change the radius on one of them to be 5 or 4 or 3. In this case, because we have a 1 millimeter radius, I'm going to do 4 millimeter. And then for this one, I think I can do a radius of, let's see, I'm going to have to dial that back. It's only going to allow me a radius of 12, I think is the max. All right, so this gets my material to be a little bit thicker. There's a couple different profiles that you can pick. This has to be between, so a row of 0.95 versus I think 0.05 was the minimum. So that's a straight conic type section. Then there's continuous curvature, and you can change the direction of the asymmetry in the profile. But here, there are a couple other things that you can include, but this allows you to get a little bit more material, a little bit, and make it a little bit thicker overall. So I'm going to go ahead and do that. But I'm going to reduce this again 1 more millimeter. So I'm going to say 3 millimeters. And I'm going to go back to the conic section at 0.05. I'm going to go back up to 4 millimeters. So this effectively turns it into a chamfer, but at 0.5, what's 0.1 look like? Just a slight curvature. I want it to be very much on the low curvature side. 2.5. There we go. 2.5 might be about right. So 0.25. So that allows us to get more material at the back without changing that base geometry, and does so without kind of disrupting some of the other form and features. You can, in this case, go a little bit beyond that and say, I actually want to go ahead and use the 5 millimeters here all the way to that outside edge of the part. And then that still won't affect that top fillet. You can still have that exist as a 1 millimeter fillet because it's just transitioning one geometry into another. But this gives you a significant increase in the strength of that part without creating what originally there was a high stress concentration where you'll be able to maybe hear by hand by just compressing the back. I can get it to flex and creak, which is not going to work well if you add a lever arm and wind loading. So this is an area where you'd need to reinforce for a 3D printed part. The other components of geometry here, not so much. The collar is already pretty thick, so it's going to be pretty strong overall, but now you've fixed some of the weak points that the 3D printing would create for this geometry. And this will be significantly stronger as an end part. So I think this will cover all of the bases for what we're trying to do in this particular part. So I'll go ahead and pause here and then check for questions and see what areas you guys are stuck on.